How did they say this in Monty Python? And now for something completely different. Um, the title has a lot of different things in it. We'll see if we can bring it together. What did these folks do for a living? It's a common question that we ask each other at parties and so on. And these folks, they mostly, fought and herded sheep, did geometry, I guess. They also dealt with a lot of dilemmas, just like we do in real life. Here's an example. It's a little bit hyperbolized, but it's actually something I'd like to talk about today, and then bring it back to materials and innovation. So maybe I'll read it, or you can read it. It says, "I carry two sorts of destiny." This is Achilles speaking. "I carry two sorts of destiny toward the day of my death. Either if I stay here and fight besides the city of the Trojans, my return home is gone, but my glory shall be everlasting. But if I return home to the beloved land of my fathers, the excellence of my glory is gone, but there will be a long life left for me, and my end in death will not come to me quickly." Okay, so the dilemma is encapsulated in those words, highlighted in red. So my return home is gone, but my glory shall be everlasting. That's if he stays and fights as a warrior, or he's got no glory, but he has a long life. And that's known typically nowadays as a trade-off. You do this, you can't have the other thing, or opportunity cost. The opportunity to pursue glory comes at the cost of long life, and so on. There's kind of a more technical term called the Pareto efficiency, and basically it says, okay, if you want more of one thing, you necessarily sort of give up the other. You're kind of stuck on this curve, or that's a frontier that limits you being able to have your cake and eat it too. Okay, that's the basic thing of it. Now what we're going to do is we're going to take this idea, this curve here, a slightly more kind of, I like to say rigorous representation, but it's a plot, okay? And we're going to break it down that way. So here's what we're going to do. So on the vertical axis is going to be glory, and you want to maximize glory if you're a warrior. And you want to become a hero, or if you're a commoner, you'd like to maximize your years. I don't necessarily care about glory, and so that's the trade-off. Now, for a person who wants to do both, there's an opportunity cost associated with each one of those choices, so we have a conflicting desires situation. And that's the diagram that represents it. So the question now is, can you have your cake and eat it too? Okay. So in the story, there's another person who's a commoner, Eumaeus. He's a swineherd. Okay, he is engaged in a normal life, is a commoner's life. And so we beget from that a high number of years, large number of years, but a low amount of glory. Okay, now that's where he sits. Okay, Achilles, he's a war hero. See, he's engaged in a life of mortal combat, as befits a hero at the time. That's what people think. And so he's on the other end of the diagram with a very small number of years and a large amount of glory. Okay. Now, so how do we do this? that's the key here, right? Why do we want to do this? We'll get to that in a minute. So what we're going to do is we're going to use a concept from math called category theory. We're going to abstract the situation into something that's a more general category. Okay. So a commoner is a person, and a person is engaged in a life that is measured with a pair of numbers for the purposes of this discussion. Okay, so commoner is a person. Not all persons are commoners. Okay, you get it, right? So a normal life is a kind of life. Not all life is a normal life, and a pair of numbers could be high, could be low in terms of the years and glory. Okay, so a war hero, Achilles in this case, maps in the same sort of way. Okay, and what happens in the story is that Homer invents a new thing. Okay, he invents a polytropos. Okay, a man of many ways. And what's happening here is very interesting. This invention is aimed at trying to have your cake and eat it too. Odysseus, the hero, a new kind of hero, is many things. He's a warrior, strategist, seafarer, storyteller, negotiator, lover, all these things that he does. Okay, so that's part one of the invention. But the other part of the invention is really interesting, is that he also introduces opportunities for him to practice those things. Okay, so there's the Odyssey that accompanies Odysseus. Okay, and so what we have now, again, with the same sort of mapping, Odysseus is a new kind of hero, still a person. Okay, he lives a new kind of life. It's still a life. But what's happening is that he's maximizing years and glory at the same time, because he's a new kind of hero. He's engaged in new kinds of activities, and he's actually employing a team of people that's helping him do that. And so we have basically what constitutes a really good invention. And actually, if you go into the patent literature and you study inventions, all really, really good inventions are about having your cake and eating it too. In more technical terms usually, but that's basically what's happening. So here's an example. This is something that we did with Matt Shtein. The two of us working together became a man of many ways, if you will. The situation with solar shells, for example, is this. There are these tilting solar shells that track the sun, and doing that gives you 40% more energy over the course of the day compared to a case where they just kind of sit there, okay, because the sun moves across the sky. Or maybe who can tell the difference? And so you have a trade-off, right? So you basically have the same kind of situation. You'd like to get more energy with this, but this setup, the tilting setup, is really big, really bulky, and there's no way that you can put it on rooftops. But you'd like to put it on rooftops because it's a very fast-growing area of solar. Rooftop installations are really, really good, and there's lots of rooftops out there. And you can't have your cake and eat it too. And so what we're saying is, well, no, we're going to try to do that sort of thing. And our invention is basically trying to do that thing by breaking it up into lots of small pieces that could all together fit into a slim package. And that's the stuff that we put on the roof. So this is basically what it looks like. So if you were here at the last days or you saw Matt Shtein's talk, that's what happens. And this is actually enabled by a new kind of semiconductor technology where the semiconductor material is very thin. It could still be very efficient, but it's mated with this kind of substrate. And then just by stretching it, you can get tilting. We've since then refined this technology to be even more efficient than this, that includes concentration and so on. And so we have the opportunity to potentially flip kind of the cost model of solar photovoltaic modules on its head very substantially. So here's an example working with collaborators in electrical engineering, taking single crystal gallium arsenide solar shells that are thin and flexible, integrating them with this Kirigami substrate. We're basically getting this power generation curve, which matches that of conventional tilting panels, but it's really small, really compact. Now it can go on rooftops. Okay, so we think that there's something generalizable about this, and this is something that needs to be practiced, but it's a rather different way of thinking, and it's something that goes contrary to what everybody's taught in school. If you've studied engineering, if you've studied law, if you've studied any economics, everybody says there's a trade-off, there's a trade-off, there's a trade-off. But actually, huge breakthroughs come from the fact that you actually break these trade-offs. So you resolve these dilemmas where you have your cake and eat it too. And the reason we have to really, really pay attention to this is that the economy is shifting in very profound ways. As this really important paper by Brian Arthur, an economist, says, the underlying mechanisms that determine economic behavior have shifted from ones of diminishing returns to ones of increasing returns. The tendency for that which is ahead to get farther ahead, for that which loses advantage to lose further advantage. And you see this in the world of economics, where, particularly in the world of technology, where some folks that start getting ahead in certain areas of technology just get further ahead and own the market. So if you look at social media in terms of market cap, Facebook is it. If you look at search, Google is pretty much it. Maybe a few Bing users, but that's about it. Book sales and all sales. Amazon is pretty big. Apple and Samsung used to split revenue in the smartphone market. Apple eats up most of the profits. 90% of the profits or greater. And that has to do with certain dynamics that happen in technology, that have to do with certain intrinsic properties of systems. It turns out that systems grow along these S-shaped curves, and the initial growth rate can be very fast. I mean, when you start things early, it's sublinear, so it's super slow, and then things take off really, really fast. And these exponential portions of the curve, these hockey sticks, as they're called in the investment community, everybody's pursuing these hockey sticks because you put in a little bit of money, it grows like crazy, and then you become a millionaire or billionaire. And so everybody's chasing these things. Unfortunately, most of our education happens over here in the efficiency portion of the curve, in the curve where it's diminishing returns. And things are just moving so fast these days that we can't afford to do this anymore. And so what we're saying is we really have to have a new kind of education. We have to produce new kinds of people that can generate these hockey sticks a little bit more quickly, more effectively, because their own ability to make a living depends on it. And what that requires, we think, is a new kind of hero, a new kind of student, a polytropos. In fact, not just a polytropos, but a polytropos, a team of multidisciplinary, cross-disciplinary experts who can do a lot of different things, both dive deep and go broad and be able to talk to each other to be more effective at this kind of dynamic. Thank you.